Hello, continue our discussion on cloud computing. Rather, if you remember the last session or the last class, we discussed on one of the computing paradigm. So, rather some of the this correlated or associated computing paradigms we are discussing in this couple of lectures. So, today what we will take up is a serverless computing, right. There is a very emerging area, and what we say that it is a buzzword which is there in this computing domain, and having lot of interest. You will find that lot of conferences and other journals, papers are coming up on serverless computing. So, we will try to see what it is, and rather in next lecture also we will see little more detail of the serverless computing, right. So, we will be covering mostly the serverless computing, and what comes back to back with it is a function as a service, even sometime a term called backend as a service, right. So, these are the two keywords. So, what we have seen in case of cloud computing, so what we see that computing as a utility, right. So, all our things is a computing as a utility, and also what we have seen that we have different models, like one is your IaaS, PaaS, SaaS, these are the predominant models, right, like infrastructure as a service, and say platform as a service, and software as a service. So, this has different manifestation, right. So, and what we try to do, you from your on premise computing infrastructure, you are hiring the computing infrastructure. But if you look at in several cases, we need to still provision the thing, right, like provision a VM, provision that what sort of a OS etcetera underlying you need to look at when the development is going on and things like that. Or rather, whether it is a your own server or a cloud server, you still are linked with the server. Primarily, I mean to say the developers are still linked, very much linked with the server, and need to have a lot of say quote unquote investment in terms of time and expertise, and sometimes this money, that how the it can be configured to use it on the things. So, this new way of looking at it, new paradigm, what we look at is the serverless computing. So, let us see that in some of different aspect how try to have a feel of the things that what it tries to say. So, it is a computing method of providing backend services on as used basis, right, as I am using or as I go on using the thing, it has been built or charged based on the things. So, the backend services, right. So, a serverless provider allows users to write and deploy code without the hassle of worrying about the underlying infrastructure, right. So, the infrastructure management is being taken out as by the serverless provider, right. So, we will see that how this FaaS or BaaS type of things which is coming into. So, serverless architecture simplifies the code development and deployment, and eliminates the need of system administration, allowing developers to focus on the core business logic, what it is looking, what he or she is looking for, without creating additional overhead like instantiating the resources such as instantiating VMs or containers, what we seen a couple of classes back, containers in monitoring the infrastructure, right. So, what it tries to do that that code developers should be involved in developing the job, rather than looking at the that backend services or the backend management and monitoring issues, right. So, if we can segregate this, or if we can provide this type of a service, things will become a much what we say beneficial to these developers, or for developing and deploying their applications. Now, what we see in this model, the developer execute their logic in form of functions. So, what we try to do that their logic is some sort of a function and submit to the cloud provider to run the task in a shared runtime environment, right. So, more develop the logic as a function. So, what we are looking as a going towards that means giving as a function as a service and submit that to the this service provider to in a shared runtime environment. So, cloud provider manages the scalability needs of the function by running multiple functions in parallel, right. So, one way of looking at it that the if I want to scale now suppose you want to scale in other way, you need to look at you need to think about that the whole thing, right, whole base of the back end etcetera, right, how things will scale and things like that, right. So, you still the provider will provide in as a IaaS service provider or PaaS or SaaS service provider, but nevertheless you need to look at the what we see that scaling factor. But here the provider basically take the scale up things based on the type of by like one is that running multiple function in parallel, right. Rather we will see that it is something which is going little bit overlapping of or something what PaaS type of service provides, right, but we will see that where it goes. So, following the wide scale application, so one thing what emerged out in recent times is that wide scale proliferation of these containers, right, or the services provided by the in form of containers. That one things which is what we see in last say couple of years or so, right. So, wide scale application of the containers, we have also seen that how easily you can take the container from say Windows to Linux to say any cloud platform. So, what they say from your desktop to laptop to cloud, it works in a seamless fashion. You do not have to go install the things of installing the things, but nevertheless you need to load, boot and if there are orchestration of the things, multiple things need to be orchestration that need to look at. Like if you remember that our previous couple of class when we were discussing about containers, especially the example scenario where we have taken up two containers, one from one is that your MySQL and PHP MyAdmin from this Docker hub, and then we can run if the Docker this engine is running. So, you can run upfront, right, but still you need to run that Docker engine, right. So, that is there, but nevertheless this container has given a different dimension to deployment of different services, especially looking at the microservices and things like that. So, following the wide scale application of containerization approach, the cloud service provider adopted to offer a better fitting containers that require less time to boot, right. So, it is something the container needs to wake up. So, or what we say less time to load or boot, and to provide increased automation in handling orchestration, that is another challenge, containers on the behalf of the client, right. So, there may be challenges of orchestration of different services. So, how it can facilitate that is another challenge which need to be managed by the which need to be realized by the the client, right. Client want to have that orchestration of services to basically realize a particular outcome. So, serverless computing promises to achieve full automation in managing fine grained container, right. So, what we coined the word called fine grained. So, this our serverless computing promises or attempts to achieve this full automation in fine grained containers in quick loading or booting up the things or automatic or handling, better handling, or in automation in handling the orchestration or containers, orchestration of containers, services and things like that. Now, so if we again try to look in that in little bit whatever we have discussed so far. So, serverless computing is a form of cloud computing. So, we are trying to realize another a form or model of cloud computing that allows users to run event driven and granular applications, right. So, triggered by the event. So, event driven and granular application without having to address the operational logic, right. So, underground whatever the back end operational logic is there, user are not bothered, but it can trigger this event driven and granular applications. So, serverless as a computing abstraction, if we look at. So, with serverless developers focus on high level abstraction as we were discussing, like function, queries, events like that, and build application that the infrastructure operates map to this concentrated resources and supporting services. So, what it is the developer is trying to do, it basically focuses on the business logic, or what we say that high level abstractions of the things, like at the function level, or you can look at the query or event level, and build application that the infrastructure operator or the service providers map to the resources and the supporting services, right. So, you build your functions, and instead of bothering that how it should run on the thing, the service provider or the serverless service provider, so to say, they take care of this mapping to the actual resources and these other supporting services, if there are any. So, developers basically focus on the core business logic and on ways to interconnect elements of business logic into complex workflows. Right? So, whenever we do have a particular application in mind, so there is a definite workflow, right. So, the developers bothered about the overall business logic and how to interconnect this workflow to achieve something, right. So, that is the that as such the developer are doing. Along with that, you do not have to manage the backend. So, service provider ensure that the serverless applications are orchestrated, that is it put into container, deployed, provisioned and available on demand. See, this is interesting, right. So, that the back end, it takes care of how the containerization has to be done, how it need to be deployed, how it need to be provisioned, and how it can be made available on demand. So, while billing the user only for the resource used, right, whatever the resource is used, that may be the billing. Anyway, that is a billing procedure, how things will work, that is one thing, but the back end thing is taking care of all these things. Okay. So, this is the way we want to say what I can say, that segregate or isolate this infrastructure management of a cloud like say VM and other things, along with that application development. So, or even container management things, etc., taken care at the back end. So, two terms come into play, we will see that one is a function as a service and another is a backend as a service, right. So, when we look at the function as a service, so client of the serverless computing can use as a basically use this function as a service model. So, when you talk about FaaS is a form of serverless computing. So, it is a form of a serverless computing in which the cloud provider manages the resource lifecycle and event driven execution of the user provided functions. So, the users or the client provide this function, and the cloud provider or the serverless computing providers takes care of the resources needed, life cycle of this process, and event execution of the user level functions, right. So, those are taken care by the cloud provider. For example, like we can so with function as a service, so user provides small statelet functions to the cloud provider, which manages the operational aspects of running the function, right. So, as if you can realize that to realize your overall applications, you have number of functions which are the workflow, but you are not bothered about or are not concerned about how the containers will be made, how it will be deployed, how this overall based on the workflow, this overall orchestration of the backend things will be there, that you are not bothered, right. So, one example available in this reference, like consider that X camera. So, it is considering some camera application which uses cloud functions and workflow to edit, transform, encode videos with low latency and cost. So, the whole application that in this so called this video application or camera application, what the application is named as X camera. So, what it is doing, it is basically wants to edit, transform, encode videos with low latency and say minimal cost. So, that is the overall objective of this application, and which is being taken care by this serverless things, right. So, a majority of tasks, if you see in these operations, what if we look at even X camera or any type of applications, can be executed concurrently, right. Some of the things we can execute, like if there is a transmission of some videos or something, I can do parallel transmission, or several things. Suppose I do some frame by frame operation, some of the things we parallel frames wise, or a group of frames and things like that we can do, right. So, even encoding etcetera. So, wherever the parallelization is possible, right. So, can be, but there are a lot of opportunity of parallelization executing concurrently, allowing the application to improve its performance through parallelizing this task, right. So, if we have that type of function as a service, then say executing multiple things by the cloud provider may improve the overall performance of these particular applications, right. So, though the picture is not good, you will find in this the references whatever given at the end. So, if we look at that evolution of serverless computing starting from 1960s, when we are having these IBM systems. So, in 70s this virtualization other things were coming up. Then when we see that in 80s this RPC implementations and RPC things were in the high node, that is that remote procedure calls. Then in 90s what we see that what that private these virtual private servers and all those things are coming up in a big way. And along with that there are other things like on the other side CGI, if you see that resources, code function, naming and registry services, functions, execution flow and different type of aspects. And what we see in 2000 is that these containers, Linux containers and other things where AWS cloud, all those things came up, Google App Engine and all those surfaced. And 2010 onwards what we are looking at that more proliferation or a big way proliferation of container services like Google Docker came in from 2013, and then Kubernetes and so forth, and other things like IaaS, PaaS, SaaS type of cloud which services, cloud based services came in a big way in a what we say what we say that is something which is deployed or being used, right. Initially it was more of a organization's own uses, but it becomes as a public services, right. So, public at large or city means different organization can have this type of third party services of the services, right. On the other hand, like if you see on the events, so that event driven architecture also 2010 onwards we see that a lot of activities there also. So, taking together what we look at that orchestration, this container orchestration and microservices is one part which are came up, or what we see it's a booming thing in these days, and which basically lead to this formation or realization of a function as a service model, and on the other hand we see that event driven workflows, right. So, we have a business workflow or my applications which is event driven. So, these things what with function as a services trying to realize this event driven workflows or this together is basically lead to this serverless computing paradigm, right, which we see, right. So, though it is came up from the is a say model based on this cloud computing paradigm and leverage on different thing these cloud computing things, but nevertheless what we see that it came up in a this event driven workflows and other side this function as a service type of things. So, so if we look at that in serverless computing cloud provider dynamically allocates and provisions servers, right. So, servers are there, right. So, only thing you have a abstraction of the things and try to realize that thing, right. The code is executed in almost stateless containers that are event triggered or event driven and maybe ephemeral, like last for one invocation and things like that, right. So, if we as we discussed the serverless attempts to cover a wide range of technology primarily grouped into two categories. One is that backend as a service, another is a function as a service. We have seen or we have discussed something on the function as a service, right. So, in these broad two categories what we try to see. So, as the backend as a service at it the name itself implies enables to replace the server side components with off the shelf services, right. So, instead of looking at the server side component, we are more looking at that services in terms of say functions and things like that, right. So, BAS enables developers to outsource all the aspects behind a scene of an application, so that the developers can choose to write and maintain our application logic in the front end. So, in other sense this all this back end load is now taken care by this back end as a service. So, I require this type of environment for my code, it takes care of the things. So, typical example scenarios are remote authentication system, database management, cloud storage, hostings, which are going at the back end of the things, right. Rather those who have used that Google Firebase, you may have seen that is a fully managed database that can be directly used from an application, right. So, that the Firebase Google Firebase I think it takes care both means NoSQL and relational model both. You please look into it. As I remember what I am telling. So, Google Firebase is a, but it is a fully realized database, right, where you can quickly connect to other applications and means quickly connect to especially these web applications and things without very seamlessly, right. So, in case of this Firebase as a say backend services as a database and things like that. So, manage data components on the users behalf, right. So, whatever the data etcetera is there, this Firebase takes care of the backend services, right. So, this is the thing which we look at when we look at the backend as a service. And the function as a service already we discussed. So, the serverless applications are event driven cloud based systems, right. So, it is not we are considering that over and above means basically my cloud system is in place, where application development relies solely on combination of third party services, right, client side logic and cloud hosted remote procedure call. See, we are not talking about any server etcetera here, right. So, it is a third party services, client side logic, the basic business logic, and the cloud hosted RPC or remote procedure calls, right. So, FAS allows developers to deploy code that upon being triggered is executed in a isolated environment. So, once it is triggered, so it is as if is executed on a server mode. So, that the things it tries to ensure. So, function are so each function typically describe a small part of the entire applications, right. So, I have the applications, what we realize is as a bunch of functions, and each function takes care of a chunk of this application. The execution time of the function is typically limited, right. So, like if you look at AWS Lambda, it is typically I think 15 minutes or so. So, it is based on the type of things, it is the execution time is limited. So, function are not constantly active, instead fast platform listen for the events that initiate the functions, right. So, function are instantiated whenever that things are that platforms are this it is triggered, right. So, thus the function are triggered by events such as client request, events produced by any external system, data stream and other things like that, right. So, it is triggered by the events, like in the camera application. I do not know that how wholly it works, but it can be event by a movement of any object of the things, it is getting triggered. It is not like that every time it is capturing and editing, filtering, means capturing, storing, filtering the image, videos, etc. But nevertheless, it is triggered by something, right. It can be triggered by some object movement, it can be triggered by something that predefined time of switching on the cameras and so on and so forth. So, the fast provider is then responsible to horizontally scale function execution response to the number of incoming events, right. So, based on the number of incoming events, the this your fast provider will scale up the things, right. So, like having different parallel execution of the function and like that. So, there are if we look at, there are not all good things, there are there are several challenges, or there are several what we say not so good things about this serverless computing. So, one is that asynchronous call, like asynchronous call to and between the serverless functions increase complexity of the system, right. So, it is asynchronous. So, usually remote API calls follow request response model and easier to implement with synchronous call. If there is a synchronous call, it is easy to implement, but if you have asynchronous call, then there is a challenge in it. Function calling other functions, that is another challenge, that complex debugging, loose isolation of features, extra cost if functions are called synchronously, as we need to pay for two functions running at the same time, that is a billing or cost wise thing, but nevertheless it becomes a more complex situation. There are issues of shared code between functions. So, might break existing serverless function, that depends on the shared code that is changed, right. So, it is based on some shared code, and that the shared code has changed, now it has to do means it has to execute the things. So, risks to hit image size limit, like typically AWS Lambda, the 50 MB is the image size limit, or warm up time, the bigger the image, longer it takes to start or load or become active. So, there are issues like that. So, usage of too many libraries, right. So, increase space used by the libraries, increase the risk to hit image size limit and so on and so forth. So, too many libraries, adaptation of too many technologies, right, such as different libraries, different frameworks, languages. Now, you have become very flexible, right. You are telling that lot of things need to be all my backend work is maintained by the provider, I only write the function based on my business logic, rest it be executed. So, it becomes too many technologies may be involved. So, add maintenance complexity and increases skill requirement for people working within the project, right. So, that who are working in the project or who are at the maintaining the things require more means skill full people, right. And at times there may be too many functions, though that already we discussed. Creation of function without reusing the existing one. So, non-active serverless function does not cost anything. So, there are a temptation that you keep create new functions instead of alternating the existing function to match change requirements, right. So, decrease maintainability and lower system understandability, right. So, what happened, a running system if you are using, so what happened that it goes for different change requests and go on updating. Now, in this case if you see that so long the function is not instantiated, so executing, so what we have the whatever it is not, you are not paying for that, right. So, while a new functions or new change request or something new is coming. So, it is there may be a tendency of updating this function, not to update, create a new function and deploy, because you do not want to disturb the previous functions and type of things, right. One may be that one psychology may be that if sometime it is coming to use, you can use. So, what happened, too many functions comes into play and it creates a problem of maintainability and of course, also overall understandability of the system, especially when you are handovering to some other things like that. So, these are some of the issues faced by the serverless computing in this paradigm. So, just to look at, there are popular things, there are many more. So, like AWS have a what we say AWS Lambda platform, whereas Google has a Google Cloud Functions or Cloud Functions for Google in the Google Cloud, and Microsoft Azure is Azure Functions. So, these are the popular things which are there and which and there are several others, right, means environment, but these are pretty popular things. There are few open source stuff also that which you can use for this serverless computing. So, Google, if you see that we have different virtual servers, these are the functions and there are databases and also different type of storage services, right, which is there. Okay. So, what we try to see that what is the overview of the serverless computing paradigm, how it helps say developers to develop and deploy their applications, looking at the core business logic in a more efficient and fast method, and is being billed or charged for the instantiation of that function instead of the whole infrastructure what it has taken now. So, with this let us conclude our discussion today. There are few references, some of the other things are taken from the internet maybe. So, these references are, you can have a look on the things. So, let us conclude our discussion today. We will continue our discussion on serverless computing in the next session. Thank you.